So, we will continue our discussion on IC engine and gas turbine, but as I said that I will be discussing about the operational principle and different components and other different features of IC engine. So, today I will discuss about 4-stroke 2-stroke engines. What are the fundamental difference between 4-stroke 2-stroke engine? In fact, I have discussed about the comparison between SI and CI engine, as well as I also discussed about the engine classification based on several issues like types of combustion and types of ignition. That is what we have discussed, that types of combustion and types of stroke. We have discussed about the classification of IC engine. So, today we will discuss about 4-stroke 2-stroke engine, comparison between SI and CI engine that we have discussed in the last class, and what are the operational principle. I mean, what is the operational principle of a 4-stroke engine or of it on a 2-stroke engine. Before I move to discuss about the difference between 4-stroke and 2-stroke engine, let us first discuss about the components that are there in a SI engine and CI engine, because we have discussed that in a SI engine a specific parts are there which are not present in a CI engine. So, let us first draw a schematic and rather a nomenclature of an SI engine. So, today I will discuss about a nomenclature of SI engine. So, that is SI engine nomenclature. Right. So, I will draw the schematic. So, this is very important because we need to draw the schematic very often while we are discussing about different other features of a 4-stroke and 2-stroke engine. So, I will discuss about then there will be valve, we also will have valve, there will be a spark plug. An important part of a SI engine is carburetor, that is here, right. So, this is carburetor, this is exhaust manifold, and this is spring loaded valve, but engine piston is operating between these 2 points. First one is known as trough dead center and bottom one is known as BDC, sometimes ODC and IDC, inner dead center and outer dead center. So, this is known as inner dead center and BDC, outer dead center, but TDC, BDC. Now, we will have a piston, but we will have a ring, piston ring, but I will tell why piston rings are provided. So, we will have a piston ring, right, and this piston ring is connected with crank and connecting rod mechanism, and so this is oil pan, this is oil pan. I will discuss one by one, and this is rotating like this. Now this valve is always spring loaded, so there will be a, this valve is always spring loaded, and connected with cam and follower. This is valve, valve spring, this is valve stem, this is rocker arm. So this is spring, valve spring, valve spring. This is valve stem, this is valve stem, this is known as spark plug, this is exhaust manifold through which exhaust gas goes out from the engine cylinder. This is cylinder wall, but in the cylinder wall we normally have one cooling water jacket to reduce the temperature of the engine cylinder, right. So this is cooling water jacket, and this is piston, this is piston, and these are piston ring, these are piston ring. So this is piston ring, and through which this is carburetor, this is air, and this is the fuel path. So air fuel is coming to the carburetor, it is mixed over there, because as I said you, that in SI engine normally air fuel mixture is introduced in the cylinder in a gaseous form. So this is cam and follower mechanism by which is connected with the this connecting rod, so that and also it is connected with spring valve. This is valve stem, and this is spark plug. So this is cam and this is cam follower. So this is cam and this is cam follower. This is cam follower, and this is intake manifold. This is intake manifold through which air fuel mixture is introduced in the engine cylinder. Now of course this is the engine cylinder. So this is the engine cylinder. So there will be reciprocating motion of the piston within the engine cylinder, that is converted to the rotary motion by means of crank and connecting rod mechanism. This is oil pan, and here we are having lubricants. So this is essentially given, this is essentially attached to this, because to provide lubrication to the wall by means of oil churning, by means of oil churning as a result of rotation of the crank, as a result of rotation of the crank, right. Due to the presence of spring, valve will be normally closed. So I am writing here, due to the presence of spring, valve will be normally closed. And to open it, we need to apply force. So to open it, force is required to be applied, right. And since this cam and cam follower mechanism is there, so cam follower cam is connected with this somehow with the engine, that rotary motion that we are converting from reciprocating motion to the rotary motion. So it will be connected to the engine, this wheel. So and spark plug is provided because as I said you, this is very much essential for SI engine, because in SI engine fuel is not, we are not utilizing the high pressure and temperature of the fuel itself, high pressure temperature of the air at the end of the compression stroke, and we need to, which is done in case of SCI engine, because in SCI engine at the end of the compression stroke the thermodynamic state of the air is such that when fuel is injected the combustion starts automatically. But in case of SI engine we need to supply an external agent which is known as spark plug, because the spark plug ignite the fuel. So this is known as carburetor, because carburetor supply air fuel mixture in a stoichiometric ratio, and it supply air fuel mixture in the engine cylinder in a gaseous form, and there is exhaust manifold through which the combustion product comes out after the combustion. So now, and piston moves between 2 points, one is top dead center, another is bottom dead center, because the piston movement is restricted between these 2 points, and above the top dead center there is a space which is known as combustion space, of course. And cooling water jacket is provided only to cool the engine cylinder, because because upon combustion, because of the combustion there will be excessive heat generation and that will increase the temperature of the engine cylinder. So we need to supply some coolant to bring the temperature of the engine cylinder to a level so that there should not be any thermal crack or engine cylinder life will increase. And oil pan is provided to supply lubricants because of by means of oil churning because of the rotation of the crank. This is what. Now piston ring is provided. So piston is, see if I draw the piston is essentially cylindrical piston, right. So piston ring is provided. At the periphery of the piston, because there will be always friction between piston and engine cylinder. Piston is very costly, so piston cylinder is provided. It is also leak proof, it won't allow combustion product to come down anyway, so and fuel to come down. So it prevents piston, because whenever friction is there between piston ring and the cylinder. So instead of replacing piston after some time, we can replace only the piston ring so that the piston life is increased. This is what. And cooling water jacket is provided, that is to provide the temperature. Now very important thing is that sometimes, as I said you, that BDC is known as IDC, inner dead center, and TDC is known as outer dead center, ODC. So piston movement is restricted between these two. So this is all about the SI engine nomenclature. Now if you would like to have nomenclature of a CI engine, only thing is that there should not be spark plug, rather we have a fuel injector through which fuel will be introduced. Instead of spark plug we will have a fuel injector, and there won't be carburetor, rather air will come through intake manifold. So this will be the difference between SI and CI engine nomenclature. So I am not going to draw the again an engine components, so that nomenclature of a CI engine can be understood. But I am telling that the instead of spark plug there will be a fuel injector through which fuel will be supplied to the engine cylinder, and instead of carburetor there should be only air intake manifold through which air will be introduced. So this is the difference between. Now even nowadays I am telling, nowadays there is no cam follower mechanism. So this valve, intake valve, and out this is intake valve, this is exhaust valve. So this is exhaust valve. So these valve opening times are controlled electronically. So but still only to have understanding how the an engine is operating and what are the different parts, and we have given this cam, I have given this cam follower and cam mechanism. Since it is spring loaded valve, so a normal tendency will be always to remain seated, not always will be closed, but upon if you need to open this we have to apply force. So this is the nomenclature of a SI engine, and now we will discuss about the strokes. So what are the 4-stroke and 2-stroke engine. So I am not, again I am telling you I am not going to discuss about the CI engine nomenclature. Nomenclature of a CI engine will be same, except there will be instead of spark plug there will be a fuel injector through which fuel will be injected into cylinder, and there won't be carburetor because air will be taken into a cylinder through intake manifold. So this is all about the nomenclature of SI engine and CI engine. So now we will discuss about the 4-stroke and 2-stroke engine. So what are the different strokes in 4-stroke and 2-stroke? Let us first discuss about 4-stroke engine, very important. As I said you that in a 4-stroke engine, I mean there are 2 revolution of the crank per 1 cycle. That means piston will move, crank will have a 2 revolution per 1 cycle. So in 1 revolution it rotates 360 degrees, so there will be 2 revolutions per 1 cycle, and piston will move from BDC to TDC, TDC to BDC like this. So now let us draw again a schematic of a SI engine, rather whatever it is, engine SI or CI. The fundamental difference between SI and CI engine is that there should not be spark plug in a CI engine, CI engine, and there will be a fuel injector, and there won't be carburetor. So this is, if I draw the again schematic of a SI engine. So this is TDC, this is BDC, just I am drawing. So this is piston, and piston is moving like this. So this is exhaust, manifold. This is, I am writing air plus fuel, it is supplied, air fuel mixture is coming from carburetor, and there will be a spark plug. So this is essentially a SI engine. So if I would like to discuss about 4 different strokes for SI engine, and that will be same for the CI engine, only in case of a CI engine we won't have spark plug, and we will have fuel injector, and only air will be introduced to the intake manifold. So this is, and we will have a intake valve, and this is exhaust valve. So this is intake manifold. So this is intake manifold, this is exhaust manifold. So here what are the different stroke? So I will discuss and I will write in detail. So initially piston is coming from TDC to BDC during intake stroke. So let me first discuss about intake stroke. So what is the intake stroke? During intake stroke, piston is coming from TDC to BDC, inlet valve opens, exhaust valve remaining closed. So a vacuum is created inside the engine cylinder, and because of the pressure difference, fuel and air in case of a SI engine, only air in case of a CI engine will be introduced into the cylinder. So I will write in details what are the different stroke, I mean the different processes involved with different strokes. So in the intake stroke, exhaust valve will remain closed, intake valve opens, piston comes from TDC to BDC, and a vacuum pressure is, a vacuum is created inside the engine cylinder. Since a vacuum is created, there will be a pressure difference between the ambient and the engine cylinder, which will allow air plus fuel mixture to be introduced in case of a SI engine, or in case of a CI engine only air to be introduced in the engine cylinder. So piston is coming from TDC to BDC in the intake stroke, and at the end of the intake stroke, cylinder is filled up with the air plus fuel in case of a SI engine, but in case of a CI engine it is filled up with only the air, and next stroke is called compression stroke. So in the compression stroke, so what you understood, I will write again, I am telling I will write in details, but what is done in intake stroke, exhaust valve is remaining closed, intake valve opens, a vacuum is created inside the cylinder, and because of a pressure difference, that is vacuum pressure inside the cylinder, and at the outside you will have atmospheric pressure. So air fuel mixture in case of a SI engine, or only air in case of a CI engine will be introduced in the engine cylinder. Whenever and this process will continue as long as piston reaches up to the BDC. So at the end of the intake stroke, piston will be at BDC, and cylinder will be filled up with the air fuel plus fuel in case of a SI engine, only air in case of a CI engine, and then whenever piston reaches at BDC, exhaust valve will remain closed, that was there, and that was initially closed. Now intake valve will closed. So next stroke is compression stroke. So at the end of the intake stroke, intake valve closed, exhaust valve is remaining closed. Now piston will move from BDC to TDC. The process is instantaneous because this will rotate. So both the valves are closed, piston is coming from BDC to TDC. The amount of air in case of a CI engine or the amount of air fuel mixture in case of a SI engine that was introduced during the intake stroke will be now compressed. So whenever piston is coming from BDC to TDC at the end of the compression stroke, so there will be a space which is known as combustion space. I will discuss about that is known as clearance volume. So air will be compressed in case of a CI engine, temperature and pressure will increase, and in case of a SI engine air fuel mixture will be compressed, and then whenever piston is reaching towards the TDC, both the valves are closed. In case of a SI engine, spark plug is ignited essentially to initiate combustion, but in case of a CI engine, since we have compressed the air and air temperature and pressure is high, so when fuel is injected through fuel injector, then the fuel itself with the contact of high pressure temperature air, the combustion will be initiated. So now what is the conclusions in this stroke, that is compression stroke? Piston is coming from BDC to TDC, both the valves are remaining closed, air plus fuel mixture will be compressed and spark plug will be ignited to initiate combustion in case of SI engine. In case of a CI engine, only air will be compressed, and towards the end of the compression stroke we have to supply fuel through fuel injector, and it will initiate combustion on account of a high pressure temperature of the compressed air. So this is all about the compression stroke. So now as I said you, the process is instantaneous, so piston will no longer remain there at the TDC. So piston will come again from TDC to BDC. So whenever piston is coming from TDC to BDC again, then this is known as power stroke. That means we had combustion already, high pressure air in case of a CI engine or air fuel mixture in case of a SI engine was there. We have initiated combustion by igniting, by switching on the spark plug or by introducing fuel in case of a CI engine. So there will be a combustion. Because of the combustion there will be huge pressure and temperature again, and that pressure will try to create a thrust on the piston face. So as I said you, there will be a piston is essentially a cylindrical shape. So at the piston face, that high pressure will create a thrust and it will allow piston to come down from TDC to BDC, and this is known as power stroke. Since at the end of the compression stroke piston was at TDC, now there will be a combustion. As a result of combustion, there will be a high pressure and temperature of the combustion product. I mean air fuel mixture it was there, that is combustion product. Now it will be combustion product. That combustion product will create a thrust on the piston face, and which will allow piston to come down from TDC to BDC, and that is known as power stroke, and both the valves are remaining closed. So during power stroke, both the valves, so from the beginning of the compression stroke till the end of the power stroke, for the timing you should know that all the valves are remaining closed, rather both the valves are remaining closed. Fine. So piston has now reached at BDC at the end of the power stroke. Next stroke is known as exhaust stroke. So what is done? So piston will come from BDC to TDC again, and whenever piston is coming from BDC to TDC, exhaust valve we need to open exhaust valve. Intake valve will remain closed, but exhaust valve will open. So as if piston is coming from BDC to TDC, it will allow all the combustion product that was there inside the engine cylinder to go out from the engine cylinder through exhaust manifold. So what is the conclusion from this stroke, exhaust stroke? Exhaust stroke, piston at the end of the power stroke, piston has reached at BDC. Exhaust stroke, piston is coming from BDC to TDC, right? And whenever piston is coming from BDC to TDC, up to the end of the power stroke, both the valves are closed. So the moment when piston is coming from BDC to TDC at the beginning of the exhaust stroke, intake valve will remain closed, but the exhaust valve will open, and the opening of the exhaust valve will allow piston is coming off, so it will create pressure on the combustion product. Because of that pressure, since exhaust valve is open, so all the combustion product will go out through exhaust manifold to the ambience. There are some issues I will discuss towards the end of this course, that whenever we are taking exhaust manifold, we may have some arrangement that are different. Those are different issues we will discuss. So these are 4 different stroke in a 4-stroke engine, no matter whether SI or CI engine. So out of this 4 stroke, so far we understood that out of these 4 different strokes, one stroke is power stroke, rather 3 other strokes, that is intake stroke, compression strokes and exhaust strokes are ideal strokes. So, 1 power stroke versus 3 ideal strokes. So, in a 4 stroke engine, there are merits and demerits also we will discuss, because since only power stroke, only the temperature, high pressure temperature is generated during combustion, that is during the power stroke, and there are 3 ideal strokes. So, engine is getting enough time to cool down. So, as compared to the 2 stroke engine, I will discuss what are the different strokes in a 2 stroke engine. So, as compared to the 2 stroke engine, 4 stroke engine gets enough time to cool down the engine cylinder. Not only that, since there are 3 ideal strokes and 1 power stroke, so the flywheel which is connected with the with the engine will have a higher higher mass, because there only power stroke is. I can give you the an example. Suppose whenever we are having huge money, we normally go to the bank to deposit the money, and when we need money, then we go to the bank and we withdraw money. Similarly, what is happening over here, during the power stroke, whatever energy is getting, that energy is stored in the flywheel, but to run the piston from BDC to TDC or TDC to BDC, whatever it is during intake, compression and exhaust stroke, we need to borrow energy from the flywheel. So, we are getting power or energy during the power stroke, that energy is stored within in the flywheel, the excess energy, because during the power stroke we are getting energy. So, some part of the energy will be used to rotate the wheel. I mean, that is why you are getting we are running the engine, we are getting whether it is 4-wheeler or 2-wheeler, we can move from one place to other place, it will try to rotate the wheel. A certain portion of the energy will be stored in the flywheel, so that we can borrow energy which is required to operate or to run 3 other strokes, that is intake stroke, compression stroke and the exhaust stroke. So, this is all about the 4 stroke different strokes in a 4 stroke engine, and now I will write in details about the what are the different strokes and what is done, and that will help you, I mean, as a note. So, now I will write in details about the different 4 stroke engines, rather sequence of a 4 stroke engine. So, the sequence of a four-stroke engine. So, what are the sequence? The sequences of a 4-stroke engine are as follows. Rather, I am writing. So, I have discussed, now I am writing. First stroke is intake stroke. Sometimes it is known as suction stroke. So, intake comma suction stroke. So, what is done? I will write in details. Exhaust valve is closed. Exhaust valve closed. Intake valve open. Piston goes down. Piston goes down from BDC to TDC, from TDC to BDC, more and more void is produced. I have discussed, but I am now writing only to I mean that will remain. So, you can also, it will remain as a note. So, I have already discussed about those. More and more void is produced inside the cylinder. Right. So, air fuel moves into the chamber cylinder. So, air plus fuel mixture in case of CI engine, in case of SI engine, and only air for CI engine moves into the chamber or engine cylinder, and this process continues up to BDC. So, process continues up to BDC. So, this is the the sequence in a intake stroke. Exhaust valve is closed, intake valve opens, piston goes down from TDC to BDC, more and more void is produced into the cylinder. Air plus fuel mixture is introduced. In case of a SI engine, only air is introduced or rather moved into the cylinder, and this process continues up to the BDC. Okay. Next stroke, that is what I told you, that is compression stroke. So, this is compression stroke. So, this is compression. What is done? Here inlet and exhaust valve are closed, rather both the inlet and exhaust valves are closed. Both the inlet and exhaust valves are closed, right? When piston reaches TD closed, piston goes off from BDC to TDC, right? When piston reaches close to TDC, right, spark plug ignites the air fuel mixture. Spark plug switch is on, and ignites the air fuel mixture. In case of a SI engine, and fuel is sprayed for CI engine. So, piston is coming, goes up from BDC to TDC, piston reaches close to TDC, spark plug switch is on and ignites the air fuel mixture in case of SI engine. Now, fuel is introduced whenever piston is close to TDC, rather at the end of the compression stroke, and it initiates combustion for a fuel is sprayed for CI engine and combustion initiates. Right, this is what is important. Next stroke is power stroke. This is very important. So, whenever at the end of the compression strokes, piston is close to TDC, we have initiated combustion, and combustion will be completed within a very small time period, and very high pressure, rather both the valves are closed, right. High pressure, a very high pressure, and high temperature. High pressure and high temperature is exerted on the piston. So, as I said you that this is very important, that both the valves are closed, and during at the end of the compression strokes already we had high pressure of the air fuel mixture or only air, and then on the top of that we have injected fuel in case of a CI engine, or we have switched on the spark plug in case of SI engine. So, it will initiate combustion, and combustion will be completed within a small time period, and as a result of which a very high pressure and temperature will be there in that space, which is known rather on the top of the piston, and that is known as clearance volume rather. And as I said you that the movement of the piston is instantaneous, so it won't remain rather at the TDC to complete the combustion. So, it is not true that the combustion will be completed as long as piston is there very close to TDC, rather it may happen that either it is happening that even when piston is coming from TDC towards BDC, combustion will continue and combustion will be completed whenever rather when the piston is little bit away from the TDC. Whatever it is, I mean the case, in fact it requires a finite amount of time, although it requires very small time period, but it requires finite amount of time to complete the combustion. So it is not true that the entire combustion will be completed when piston exactly at the TDC. So maybe piston continues to travel from TDC towards BDC and combustion will be completed. Now power stroke is both the valves are closed, a very high pressure and high temperature is exerted because of the combustion on the piston face. On the piston, this is very important, and this create a thrust on the piston face, a thrust on the piston face, and because of this piston again moves from TDC to BDC. So piston movement is instantaneous, so I can't say that piston will remain over there at TDC, but maybe piston is started journey from TDC towards BDC at the beginning of the power stroke, but whenever piston is coming from TDC to BDC, we are already combustion has initiated and combustion will be completed maybe whenever piston is little bit away from the TDC. So that high pressure and temperature that is generated because of the combustion will create a huge thrust on the piston face, and which will allow piston to move down. I mean that is create a power. So this is and from TDC, and this is the power stroke, and this is the power stroke. This is the power stroke, right? This is important. Now last stroke is known as exhaust stroke. This is very important, exhaust stroke. So we have discussed about all these strokes a few minutes back, but still I am writing. So till now we have discussed about intake stroke, compression strokes, power stroke. So we have seen that, I will discuss again. Exhaust stroke, intake valve is closed, intake valve remaining closed, exhaust valve open, right? This is simultaneous. So process is simultaneous, that is intake valve remaining closed, exhaust valve open simultaneous, which means that, and exhaust valve open, piston moves off from BDC to TDC, intake valve remaining closed, intake valve is remaining closed, exhaust valve open, the process is simultaneous. I mean these two are valve opening are simultaneous, and as I said you that nowadays all these valve opening times are controlled by electronically. Piston moves up from BDC to TDC. So from BDC to TDC piston is coming off, and so whenever piston is coming up and whenever piston reaches at the TDC at the BDC during the end of power stroke, entire combustion is completed. Now the cylinder space will be filled up with the combustion product. So at the beginning of the power exhaust stroke, when piston is coming from BDC to TDC, it will allow the combustion product, rather it will expel combustion product to go out through intake through exhaust manifold BDC to TDC, and the product of combustion and the movement of the piston and the movement of the piston and the movement of the piston will allow, rather will expel, will allow the combustion product to go out through exhaust manifold, right. So this is what, so this is, there is a difference between exhaust stroke, and there is a difference between 2-stroke and 4-stroke engine for the exhaust stroke. So this is happening. So I will discuss in 2-stroke engine. 2-stroke engine, there are no intake, power stroke is there because you will power, but intake, compression, exhaust strokes are one stroke. We have to complete all 3 stroke in all 3 different strokes in a one stroke. So we will discuss in detail about this, very interesting and fun, So only you will have a one idle stroke versus one power stroke. So power stroke will be there, but remaining 3 strokes will be completed in one stroke only. So the sequences of a 2-stroke engine we will discuss, but now we have understood that what are the 4 different strokes in a 4-stroke engine, whether it is SI or CI engine. So intake valve is remaining closed, exhaust valve open, piston moves up. Whenever piston is moving up, the cylinder space was filled up with that is the beginning of the exhaust strokes or end of the power stroke. Entire cylinder space is filled up with the combustion product. So the movement of the piston from BDC to TDC will expel all the exhaust gas or combustion product to go out through exhaust manifold. So these are the 4 different sequences of 4 different strokes, and the process continues. This is cyclic, so cycle in a cyclic manner. So the process continues, the process repeat again from intake, compression, power and exhaust. So as the end of the exhaust stroke, piston cylinder space is relatively empty, there is no combustion product. I can't say that there won't be combustion product, there will be a residue, but again we will have a suction stroke, intake stroke. So we will have again, we will introduce fresh air, and again all the process will be repeated, and it will continue. So these are the 4 different stroke in a 4-stroke engine, but I would like to discuss a few points in the context of this, that maybe as I said you that it is not possible that the entire combustion will be completed. So whenever piston will be exactly at the TDC, combustion will be initiated and it will be completed whenever piston is supposed to departure from TDC towards VDC. It is not the case. So there is a deviation. So maybe we have to initiate combustion when the piston is a little bit away from the TDC, and the moment when piston reaches at TDC, maybe entire combustion will be completed, and it may not be case that the entire combustion will be completed exactly when piston is at the TDC. Rather, whenever piston is again traveling back from TDC to BDC, combustion continues and combustion will be completed when its piston away from TDC. So that is the case, and because of that there will be certain problems. That is what I will discuss in details. And not only that, in the exhaust stroke, it is not possible that all the combustion product will go out, rather can be expelled out from the engine cylinder. There are remote areas from where combustion product will be there. So whenever again we are taking fresh air during the intake stroke, in case of a CI engine or in case of a SI engine where we are introducing again fresh air fuel mixture, that fresh air fuel mixture will be mixed with the residue of the combustion product, and as a result of which engine efficiency will drop. So that is what we will discuss in detail again. But for the timing, you should know that in case of a 4-stroke engine, since only one power stroke, that is from where we are getting energy or power, and that power will be utilized to rotate the wheel, and we can run our vehicle, 4-wheelers, 2-wheelers, whatever it is. But a part of the energy will be stored in the flywheel, because we need to run intake, compression and exhaust stroke, for which we need energy. Now that energy will come from the flywheel. That means power stroke we are getting power that is remaining stored in the flywheel, and for 3 different other strokes we are again borrowing energy from the flywheel. So this is the 4-stroke engine. And another important point is that since in a 4-stroke engine only we have only 1 power stroke versus 3 ideal strokes, so engine cylinder is getting enough time to cool down, whereas in case of a 2-stroke engine we will have only 1 power stroke versus 1 idle stroke, so engine is not getting enough time to cool down. So in 4-stroke engines is relatively safer from that perspective. Not only that, we will discuss in detail that in case of a 2-stroke engine, highly possibility is there that some amount of fresh air fuel mixture will go out with the exhaust product, and that is not the case in case of a 4-stroke engine, because 4-stroke engine, once the exhaust stroke is completed, exhaust valve will be closed immediately, and then only intake valve will open and will introduce air fuel mixture. Maybe we won't have loss of fresh air fuel mixture or fresh air with the exhaust stroke, but still probability is there that some portion of the combustion product, the residue of the combustion product will be there in the engine cylinder in the remote areas, and which will be mixed with the air fuel mixture that is coming during intake stroke in case of a SI engine, or fresh air in case of a CI engine. So this is all about the sequence of a 4-stroke engine, but we will discuss about the 2-stroke engine in the next class, and we will see that how the 2-stroke engine is differing from the 4-stroke engine, and nowadays why 2-stroke engine is not are not preferred. 2-stroke engine are not preferred, rather all engines are 4-stroke engine. So those issues we will discuss in the next class. With this I stop here today, and we will continue our discussion in the next class. Thank you very much.